Alright, so this equation has fractions. And normally when solving an equation with fractions, it's a great decision to get rid of the fractions, to remove the fractions. And to do so, we need to multiply by the common denominator. When we have an equation like this, in order to identify the common denominator, the denominators need to be factored first. So that's what I'm going to do first. I'm going to factor the denominators. So we have 5x over x squared minus 25 is the difference of two squares, and that'll factor into x plus 5 times x minus 5. And we have 25 over x plus 5 times x minus 5 again. And the last quotient doesn't require any factoring. And so now what I'm going to do is put parentheses or brackets around the equation, and I'm going to multiply the equation by the common denominator. The common denominator is x plus 5 times x minus 5. The common denominator, the lowest common denominator, it's the minimum that I need to cancel out each of the denominators, each of the fractions. To cancel out the first quotient, to cancel out the fraction on the first quotient, I need an x plus 5 x minus 5. And so I need to put an x plus 5 x minus 5 on the outside. And that takes care of the next one. And on the third quotient, all I need is an x plus 5. And so x plus 5 times x minus 5 is the minimum expressions I need to cancel out each of the denominators. So now we're going to take the common denominator here and distribute it. When I multiply the common denominator by the first expression, the x plus 5 and the x plus 5 cancel and the x minus 5's cancel. So I'm left with 5x equals. And then when I multiply the common denominator by the next expression, once again, the two binomials x plus 5 and x minus 5 cancel out with the two binomials on the bottom, and I'm left with just 25. And finally, when I multiply the common denominator by the last expression, what happens is the x plus 5 cancels with the x plus 5 below the 3, but the x minus 5 is preserved. So we have 3 times the x minus 5. And at this point, the fractions are gone, and so the equation is much more manageable. The next thing we do is distribute the 3, or the negative 3. And then now I'm going to add 3x to both sides, giving me 8x on the left, and I can combine the 25 and 15, and dividing by 8 I get 5. And so 5 is the proposed solution. Now, sometimes we can actually solve an equation, we can do everything right, but the answer has to be discarded. You know, it's not all equations have this potential, you know, for what's called extraneous answers. An extraneous solution is basically a solution where I do everything right, but the answer that I get fails to satisfy the original equation. Notice that if we take our proposed answer 5 and you plug it into one of the bottoms, you know, if we were to plug it into x squared minus 25 up here in the original equation, we would end up getting 0. Right? If I take 5, once again, if I take 5 and I plug it into the denominator of one of those expressions on the original equation, I end up getting 0. And so that's an undefined expression. So the reason why 5 is not a valid solution is because it doesn't satisfy the original equation. You know, and the bottom line is anytime I'm solving an equation and there's variables on the bottom of the original equation, such as this one I'm writing down over here, that means I have to be on the lookout for extraneous solutions. If I were to solve this equation over here, and if I were to get x equals negative 3, notice that would give me 0 in the bottom, and I have to discard this solution. Once again, it's called an extraneous answer. But we don't know if we're going to get an extraneous answer or not, you know, before we solve it. So now that I've solved this equation, I see that I can take 5 and I put it in, I get 0 in the bottom, so it has to be discarded. And again, it's called, when this happens, it's called an extraneous solution. And there are no other proposed answers, so the answer to this equation, the answer to the problem, is no solution. This equation doesn't have any solutions. So no solution is what I would want to indicate as my answer.